Good morning, everyone. I am R. Monica Lakshmi from the Department of Computer Science and Associate Systems in RMD Engineering College. So today we are going to see about computer architecture classification, which was designed by Flynn. So Flynn's taxonomy uses two basic concepts. One is parallelism in instruction stream. The other one is parallelism in data stream. So there exist four possible combinations. One is single instruction stream, single data stream. The second one is single instruction stream, multiple data stream. The third one is multiple instruction stream, single data stream. And the fourth one is multiple instruction stream and multiple data stream. So first we'll see single instruction, single data stream. So if this particular processor can do only one job at a time, so we'll see how that functioning is done. So first, each time when the program to be executed will be stored in the memory. So from the memory, the instruction will be loaded to the control unit. So in control unit, what it is going to do is it is decode the instruction, because the computer can understand only machine language, that is zeros and ones. Only binary language could be understood by the computer. Our high level language could not be understood. So the decoding is done in this control unit. Then the decoded instruction will be sent to the processor unit, where the particular instruction will be processed in this processor unit. The instruction has been sent here, it is going to be processed here. So the instruction has arrived in processor unit. Now it is in need of the data. So initially only the instruction has been given to the control unit and the data resides in the memory module. Now from the processor unit, the data will be taken from the memory module. The data is taken and with that data, the instruction is processed and the result will be reloaded to the memory module. So this is the overall functioning of the single instruction stream and single data stream. So we have only one instruction is given to the controller. There is processor can do only one job at a time, and that instruction will be processed and the result will be stored. The next instruction will be sent to the control unit. Similarly, the same process is going to be repeated. So this is single instruction stream and single data stream. So this particular processor type was used initially, but now it is not in practice. The second one is single instruction stream and multiple data stream. So here we have only one control unit and we have multiple processor units. So the control unit will fetch the instruction from the memory. The control unit fetches the instruction and it is going to decode the instruction, and the decoded instruction will be sent to the processing unit, where the data are going to be processed. Okay, so we see this with an example, that's diagrammatical representation. So this is the diagrammatical representation of SIMD. So initially from the memory module, the data, that is the instruction, will be loaded to the control unit. Instruction is loaded to the control unit. In the control unit, the instruction is decoded and the decoded instruction will be sent to the processor unit. So we don't have one processor unit, we have n processor units, but control unit is value 1, but the processor unit is n processor unit. From the processor unit, it is in need of the data. So what each processor unit is going to do is it fetches the data that is required for that particular instruction from the memory module, and it processes and it stores the result back to the memory module. So for example, we can consider the matrix multiplication. So for matrix multiplication, the common instruction is matrix multiplication, but it is going to operate on different set of rows and columns. So that is going to be processed in each processor. So this is the single instruction stream and multiple data stream. And the third one is multiple instruction stream and single data stream. So this is the rare type. We don't use this particular type of processor. So here what we are going to do is from the memory module, the instruction is being fetched to the control unit. So we have multiple instructions. So from second memory module, the instruction will be fetched to the second control unit. Then from the nth memory module, the nth instruction will be fetched and it will be loaded to the control unit. So what the control unit will do, as in the previous, the control unit decodes the instruction and the decoded instruction will be sent to each processor unit. The instruction has been now arrived at processor unit. Now what happens is, in the previous case, the data from the memory module was given in parallel to each processor unit, but in this particular system, here we have only single data. So the data will be loaded from the memory module to the processor unit, first processor unit. This processes, and this processor unit will be waiting for the result that is produced from this processor unit. So it takes the result from this processor and it is given to this processor unit 2. And this process will be continued up to processor unit n, and finally the produced result will be loaded to the memory module. So this is a concept of multiple instruction stream and single data. So we have multiple instructions are loaded to the control unit, but only we have single data to be loaded to the processor unit. So this is the third type. So this is not in use. The fourth type is multiple instruction stream and multiple data stream. So this is generally that is in use, the common processor. So we'll see the working. So from the memory, so for an instruction to be operated, it should be loaded in the memory. From the memory, it is going to be loaded to the control unit. The instruction is loaded to the control unit. So each instruction, we have multiple instructions. So multiple instructions are loaded to the multiple control unit. So each control unit, what it will do is, the whatever instruction it has got, it is going to decode that particular instruction. The decoded instruction will be sent to the processor unit. We have n processor unit also. So the decoded instruction will be sent to the processor unit. And what the processor unit will do is, it is going to process the data that is simultaneously. Each processor unit is going to work on the data simultaneously for different instructions. So the processor unit fetches the data. So first the instruction unknown will be loaded to the control unit. Now the data will be taken from the memory module, the processor unit processes, and it produces the result, and it will be loaded to the memory module. So this is the fourth type. So this is generally we use this type of processor only. Multiple instructions will be loaded to the control unit. It will be decoded, and the decoded instruction will be sent to the processor unit, and the processor unit is going to process the instruction. When processing the instruction, it is in need of the data. What it will do is, it fetches the data from the memory module, and it uses the data, and particular computation will be performed at the processor unit, and the result will be stored back to the memory module. So these are the four types of classification of Flynn. Okay, so single instruction stream, single data stream. Second one is single instruction stream, multiple data stream. Third one is multiple instruction stream, multiple single data stream. And the fourth one is multiple instruction stream, multiple data stream. So this is going to be Flynn's classification. Thank you all.